Now we'll talk about how to build one table from another table. That's called projecting a table. And select statements project existing tables into new tables. A select statement can specify an input table from a from clause. And almost all select statements that you'll encounter in the world have from in them. So I talked before about how you could have a column description, which is a bunch of expressions and names separated by commas. That's the column description. You have to know where the columns are coming from. That's using from. And then you give a name of an existing table. After that, you pick which rows from the existing table you want to keep in the output. You want to choose the order of the output. And now you have the elements of a common select statement, which takes an existing table, picks some of the rows, orders them, and then picks some of the columns or builds new columns using expressions to describe what columns you want. Column descriptions determine how each input row is projected to an output row or result row. So let's pull back in our dog family tree and think about what we might ask. What is the child from the parents table where parent equals Ace would list out both Bella and Charlie, the two child values, where in the original parents table, the parent value was Ace. So to revisit what's going on, we pick a table to start with. This original table had a lot of rows. Only two of those rows had a parent value of Ace. When I write parent, I'm using the name of one of the columns in the parents table. Child is also the name of a column in the original table. And the reason I only see child in the end is that that's all I selected. That was the column description that I provided. Let's do another example. Select parent from parents, where parent greater than child. This will test their alphabetical order. So E comes before F, so the parent is not greater than the child. But F comes after D, and F comes after A, so we have two cases where the parent is greater than the child, Finn Ace and Finn Daisy. So we list both of those rows out, but only the parent. And we get Finn Finn. This was from Finn Daisy, this was from Finn Ace, but we no longer see the name of the child, so we only see the parent, because that's what we asked for in the column description. Use quotes when you're talking about a particular value. Use no quotes when you're talking about a column. You don't have to write anything extra to go through all the rows of the original table. That's just what a select statement does. It considers all rows of a table, picks out some ones that are interesting, and then writes down some information about each of those rows. Let's try some variants. Here's my parents table in a text file. I'll open up SQLite and initialize it with the parents table. I'll go into column mode because it looks nicer. I can select all rows by just writing select child from the parents table. Since there's no where clause, it keeps them all. If I want to switch the order of the child and the parent, I would just write select child, comma, parent. But if I only want some rows, for example, where the parent equals Ace, now I have only some of the rows from what I typed before. And here I can see Bella Ace and Charlie Ace because I asked for both the child and the parent. But if I ask for only the child and not the parent, then the resulting table has the same number of rows but one fewer column.